Good morning everyone. I am D. Sengotayan, Assistant Professor of Physics, SNS, College of Technology, Coimbatore. Today our topic is about magnetism, Introduction to Magnetic Materials. So in this video we will discuss about basic terms and definition involved in magnetism, then origin of the magnetic movement, classification of the magnetic materials, then finally domain theory of ferromagnetism. And the title is about magnetic dipoles. We all know that a system consisting of two equal and opposite poles separated by a small distance L. Then the magnetic dipole moment, that is magnetic movement associated with the magnetic dipole or a paramagnetic, it is the product of both strength and length of the magnet. Then the space around the magnet or the current carrying conductor where the magnetic effect is felt is called magnetic field. That means magnetic energy or magnetic effect is felt. The diagram shows that the space around the magnet. The magnetic lines of force, it means magnetic field is assumed to consist of lines of magnetic forces. It is defined as the continuous curve in the magnetical field. So the number of lines of force passing through the materials, that means magnetic intensity or magnetic lines of force. The punch or curve of magnetic lines of force are called magnetic flux. Then the diagram shows the amount of energy passing through the materials. Then the next title is about magnetic induction or magnetic flux density. The number of magnetic lines of forces passing through the unitary cross section is called magnetic flux density. Then the magnetization or intensity of magnetization, it is the process of converting non-magnet to magnetic materials or the magnetic moment per unit volume. Then next classification or types of magnetic materials. There are three types, that means diamagnetism, paramagnetism and ferromagnetism. For diamagnetism, it is also called non-magnet. The magnetic lines of force not passing through the materials. So all the electrons or atoms or molecules in diamagnetism will align perpendicular to the applied field so that lines of force not passing through the materials. Then paramagnetism, it means 70-30, the number of lines of force passing through the materials. Then the ferromagnetism, it is very strong magnet. So all lines of force passing through the materials. So basically number of lines of force accepting or passing through the materials depends upon the energy received. Classification, basically three types, that is dia and para and ferromagnetism. Then the hysteresis curve, it means hysteresis loop or hysteresis energy. So initially energy is equal to 0. So the material placed in a magnetic field, for example ferromagnetic material placed in a magnetic field, the amount of energy passing through the material, that means maximum value equal to O2A, that saturation value. So hence once the applied magnetic energy is equal to 0, the amount of energy retained by the material is called reductivity. Then coincident, it means the amount of reverse field required for reductivity value is equal to 0. So finally reverse energy is required. So magnetic force or energy increases in the opposite direction, that means C to D. So finally the amount of energy applied in the negative direction is equal to negative direction saturation. So in the graph shows that starting point O, then A equal to positive maximum value, then A to B, then B to C equal to reductivity, then C to D the negative direction maximum value, then D to E, F. So finally the cycle of magnetism is called hysteresis. So depends upon the amount of energy applied, then amount of energy retained, then amount of reverse field required. Basically there are two different types of materials, soft and hard magnetism. If the material or hysteresis loop is very narrow, it is called soft magnetism. Then the hysteresis loop is very length or hard magnetism. So in soft magnetism, once magnetizates and demagnetize is easy, but in hard magnetism that is very strong materials, so it is not easy to apply magnetic field and also reverse magnetic field. So depends upon the soft and hard magnetic materials. These materials used for temporary and permanent magnets. So magnetic materials basically depends upon the amount of magnetic lines or force passing through the materials. It depends upon the magnetic lines, magnetic field and magnetic lines or magnetic flux density and intensity of magnetization or magnetic field density. Then finally the amount of energy passing, that means susceptibility and permeability. So P by H and I by H, I equal to intensity of magnetization, then H equal to magnetic field. So the ratio between I by H equal to susceptibility, then ratio between P by H equal to permeability. So these two titles playing important role to the identifying the magnetic materials. So these are the basic terms and definition of magnetic materials. Thank you.